In 600 million years, if things continue as they are, a day will last an hour longer. To be fair, it will also be a lot warmer. But what if we could pause the future and spend an extra 61-minute day doing something fun like, I don't know, remedying the climate crisis? If we did, we might notice something strange. Days aren't 24 hours anymore. In fact, our 24-hour days are already a thing of the past. This means that, on average, the length of a day increases by around 1.8 seconds per century. 600 million years ago, a day lasted just 21 hours. That's because the Earth doesn't spin at a fixed speed. It naturally speeds up and slows down. And we recently had the shortest day ever. On June 29th, Earth completed a rotation 1.59 milliseconds faster than the standard 24 hours. It might seem like a small change, but this is a big deal. That's because atomic clocks, which are the most accurate clocks we have, can detect even microsecond differences in the Earth's rotation speed. Now, atomic clocks are so sensitive that they reused to define the international system of units and keep time not just for us humans but for satellites, telecommunications, and all kinds of technologies that require precise timekeeping. They even help scientists spot the recent record-breaking short day. In fact, the reason we even know that the Earth's rotation is slowing down is because of atomic clocks. In the 1970s, scientists noticed that the Earth was slowing down by almost 2 milliseconds every century. They've been watching it speed up a little bit since then, though the recent rate is about 1.7 milliseconds per century. But what is really interesting is that it sped up significantly from 2020 to 2022. Instead of speeding up by 1.7 milliseconds between 2020 and 2021, the Earth only took 1.5 milliseconds to do it, and the difference between 2021 and 2022 was even smaller at 0.8 milliseconds. There are lots of other records being broken right now, like the tallest waterfall on Earth, or the longest fingernails ever grown. These superlatives make headlines, but the rotation of the Earth is changing too. And while it seems like a small change, it's actually big enough to mess with our global systems, and may even cause problems like earthquakes. So let's get to the bottom of why the Earth's rotation is speeding up, how much it might change our lives, and whether we should trust the ground beneath our feet. So the Earth isn't spinning any faster overall. Its rotation isn't speeding up. It's just getting faster sometimes. Specifically, it spins fastest during the summer in the northern hemisphere. And that's because glaciers, big masses of ice left over from the last ice age, are melting. Since glaciers are heavier than rock and dirt, removing them lets the land rebound upward. Basically, it is a very slow version of pushing down on a trampoline and then taking your weight off to watch it bounce back up. And this glacial rebound is constantly rearranging Earth's crust, redistributing mass, and slightly altering the planet's rotation speed. We also know that big earthquakes and volcanic eruptions can speed up or slow down Earth's rotation by shifting where the planet's mass is distributed. But those effects tend to only last a few weeks or months. Something else is going on that's slower and more steady. Though the Earth's rotation might be affected by many different things, there's one main culprit behind the slowdown that's been happening since the 1970s. The Moon. Over billions of years, the Moon's gravity has slowed Earth's rotation through tidal forces, and it is expected to keep doing this until the Moon is so far away that its gravitational pull no longer has a significant effect on our planet. And that won't happen for another 50 billion years. But in the meantime, the Moon is dragging us down. By some estimates, it slows us down by about 1.7 milliseconds per century. But as I said, the Earth's rotation is speeding up, so there must be something else going on. Some scientists think the Moon isn't the only celestial body affecting our planet. While the Moon does slow down our rotation, the Sun speeds it up, and the two effects cancel each other out. But the Sun and the Earth are getting further apart as our planet moves into the next phase of its orbit. And if that happens quicker than the Moon drifts away from Earth, then the Moon's gravitational influence will become stronger, which would slow down our planet faster. So the Earth might be spinning faster because it's getting harder to break the planet's inertia. But that's not the only possible explanation. Others say that the Sun's heat is actually melting the North Pole, which means it's also losing mass. And that loss of mass makes the pole less effective at slowing down the Earth's rotation. Still, others point to the Chandler wobble, a natural wobble in the Earth's rotational axis that occurs every 14 months or so. What's really weird is that the Chandler wobble seems to be speeding up too. There are also more complicated explanations. Some researchers believe the inner core of the Earth is rattling around inside the outer core like a shaken bottle of soda. Only instead of making a fizzy drink, It's creating seismic waves that speed up the Earth's rotation. Others say that as the sun gets older and begins its red giant phase, its gravity will start tugging on the Earth and pulling it towards the star. That would make the planet shrink and speed up. But these explanations are more speculative. We need more data to determine why the Earth's rotation is speeding up again. Scientists were so surprised when they saw the sudden change that they started to debate what was causing it, but they can't agree. So far, the leading hypothesis points to melting ice. As the climate crisis accelerates and temperatures rise, glaciers and ice sheets are melting faster than they're reforming. That leaves less mass at the poles, which are closer to the Earth's rotational axis. And less mass there means the Earth rotates faster. And since we're warming the planet faster than ever, we may see the Earth rotating even faster in the near future. Even if we haven't triggered the fast rotation ourselves, we could soon be dealing with its consequences. You see, our telecommunications, GPS and other technologies that require precise timing rely on satellites orbiting the Earth. If the Earth starts spinning faster, those satellites will feel the effects. In fact, the Earth's rotational speed affects their orbit so much that engineers have to account for it when launching new satellites. So if the Earth starts spinning faster unexpectedly, it could knock existing satellites out of sync, disrupting our communications, banking systems, internet and everything else that depends on accurate timekeeping. Right now, the changes are small enough that satellites can compensate, but if the speeding up continues, there might not be any way to counteract the disruption. That's not to mention the other potential risks of the Earth suddenly rotating faster. When the planet loses mass at the poles, the forces that shape our tectonic plates get disrupted. And as we've seen, volcanoes and earthquakes can speed up or slow down the Earth's rotation. So while it might be hard to imagine, we could face strong earthquakes and volcanic activity as the planet adjusts to its new distribution of mass. For now, the good news is that scientists can usually predict when these events will occur. They can measure shifts in the Earth's rotation and use that knowledge to track tectonic plate movement and assess earthquake risk. For example, in September 2021, a magnitude 7.3 earthquake in Mexico caused the Earth to rotate 1.2 milliseconds faster. But if the Earth starts spinning faster without the usual warning signs, we may not have time to prepare for what comes next. And what comes next could include a negative leap second, a technical term that means removing 1 second from the last minute of the day. A negative leap second has never been executed before, but it may be necessary if the Earth starts spinning faster and threatens to throw off our global timekeeping systems. Not that it would be easy. There are challenges to implementing a negative leap second. You need to make sure everyone who relies on precise time, like satellite operators, transitions smoothly. Otherwise, computers might lose a second somewhere along the line and end up a whole second behind. That would cause all kinds of chaos. In the end, negative leap seconds might be the least of our worries. While the Earth is spinning faster, it's still too soon to say why. We might not know the answer for years, which means we can't tell how quickly things will change. The Earth might just be wobbling, or it could be speeding up forever. Either way, we need to keep tabs on our planet and improve our timekeeping technology, because while you probably don't notice the change, the Earth's rotation is constantly evolving. And as we learn more about it, we can solve more problems before they take us by surprise.